Thank you for the compliment. So now I'd like to invite Nicodemus to take us through his presentation.
Good afternoon, everyone. I hope you're doing well. Thank you, Joy, for all those flowers that you've given to our team, and you're much grateful for that. I hope you can hear me and you have had a good lunch, and welcome to this lesson. Yeah, you can hear me? Nice. That is good.
Yes, we can hear you.
Yeah, so I think I can now share my screen. Just a little bit. Yes. Right. Just a little bit. Yes, I think you can confirm to me whether you can see my screen. Able to see my screen. Nice. Thank you. Thank you so much. Yes, I'll move to the next topic that we are supposed to do today. Let me just move to the databases. Yeah, here they are. So, of course, Angela and Leonard have helped us appreciate our introduction to databases and interaction and also the data types. Yeah, so the next thing that you're going to look into is inserting data into the database. So I think, yeah, I use the Canvas slides, so you can just go through together and just help to see how we could insert data into the databases. Yeah, so my notes are opening up. Nice, let me just go to the top. Yeah, so of course, welcome to inserting data into the databases. So this is what you will learn in this topic. Yeah, of course, at the core of this lesson, we will learn how we learn this being able to import a comma separated values, that is the .csv file, into a table. Yeah, but also you'll be able to see and be able to learn the list of common reasons for cleaning data. Why should we clean data? And probably what causes data errors and why should you clean it? And also now inserting rows into an existing table. So of course, the bit of importing it into the .csv into a table and being able to clean the data and inserting it into the table. And we'll have, of course, we'll have these three key terms, which we will interact with them over and over. And the first being insert into statement, yeah, and describe statement and the null statement. Yeah, so I think just to start off, probably I'm not able to see the comments, yeah, but I think Kulebo, just to first appreciate and help us understand what is a CSV. Yeah, because I think our data, of course, we will store it and create it in a .csv file. So we need first to appreciate what is a CSV. Yeah, and of course, a CSV is a simple text file in which the information is separated by commas. So like as you can see here on the right side of my screen, so a simple plain text like this one, ABW, Aruba, and they're separated by commas. And that is how data is stored in a CSV. file. But when it's viewed on the tables, as Angela had had helped us appreciate, we find that it will appear as columns and rows. So that the column will be the ones, of course, the rows being these ones, and yeah, and the columns, yeah, being displayed there clearly. Yeah, so like here, of course, now when you view it in the table, you have the country code here as ABW, AFG, AGO, yeah, similar to the name, the continent, and the surface. Yeah, so that is how a CSV basically is. It's a plain text that is separated by commas. Yeah, but when viewed in a table format, it has columns and rows. Yeah, yeah. So I think now to our topic, importing data and exporting data, because there are two ways of how to import data. Yeah, one being this one, because I think these three steps, you need to understand them very well, because they're crucial in you understanding how to import data, like that is a CSV, into a database. Of course, the first thing that you need to do is to verify that the CSV file has data. And this data, of course, it should match the number of columns in the table, but also the type of data in each column. So you need to verify that first. So this is our first step that we need to look before we import any data. We need to verify that if it has if the number of columns of the table, it matches with the number of columns in the table, and also the type of data in each column. So that is the first step that we have to do. Yeah, but the second step is to create now the table. So after we have verified and we know that our data has this number of columns and it has this type of data in each column, now we create our table that corresponds to the CSV that we want to import. Yeah, so of course, knowing that we have probably 4 columns, our table will have 4 columns. Knowing that we have probably different data types like the integers, the float, as Leonard helped us to appreciate, yeah, the different data types. So now you will associate each column to the different data types. But now the last step is importing, which we use this statement, load data. So this is the last step of importing a CSV. So you import using the statement load data. Yeah, and there are a few things to check here. If the first row of the file contains the columns or the headers, you ignore the rows. Yeah, you ignore one row's clause to ignore the first row. Yeah, that is if it contains the columns and headers. Yeah, but if the row in the file are terminated by a new line, you terminate it. They're terminated using the /n. Yeah, I think people who did coding in C++, C++, I think. Yeah, you could appreciate that there was this new line, next line. Yeah, that we use. It means that you terminate there and go to the next line. Yeah, so the second way of importing data, we could use now this code, which of course use load data in file. Yeah, so then the probably your file is in C under a temporary, and then it's called city.csv. So this is the file that you want to import into a table that is called city. Yeah, so you write that statement and you import the .csv file into the table city. Yeah, and now of course you need to include that the fields need to be terminated by the comma, knowing that it's a CSV file, so they are separated by the comma. Yeah, so you include that one, but also they need to be enclosed by this quotation mark and the lines to be terminated by this /n. Yeah, to ignore your row ya kwanza. Yeah, I think moving on to the second bit, exporting a CSV. Yeah, so this is probably a code that I think we could do practical later. Yeah, I hope we'll have time probably to do the practical bit, but this is how probably you can export a CSV into probably, let's say we want to export the CSV that we have, that is, we need to export our data into a file that is in a temporary, and it's my SQL files, and we are calling it city.csv, and we want to import data from a table which is called city. We have to export data from a table which is called city. So of course the select statement, we will see it in the next class. So this one just help us to select the number of probably the columns that we want to be exported. So if probably our city has the ID column, the name column, and the country column, so we state them there. We want to select the ID column, the name column, and the country code from our table, which is city, and we need into an out file, which our file is called city.csv, and it is in this folder, and we want to export our data from this table to this folder. Yeah, so then you also include the other things, that the fields need to be terminated by the comma and then closed by the quotation marks and the lines and the next line. Yeah, so yeah, I think probably I could hear just from you. Why do you think that we need to clean data? Moving on to the next bit. Yeah, I think someone could just unmute and talk, or probably write in the chats, why do we need to clean data? I see Abby says that ensure the analysis done is accurate. Thank you, Abby. Felix, nice. It eliminates errors. Nsembi says that resolves discrepancies. Nice. That is great. Thank you for those engagements. Yeah, and cleaning data actually is important. We have seen that when we of course, us having data, we'll be able to import it or export it into our tables, or our data into our database. And through that, we find that this data, it might contain some errors when we are doing the importing and the exportation of the data into our CSV files, either into the database, or now we want to export from the database to a CSV. We find that the data could be corrupted, and that one necessitates the need for the cleaning. Yeah, and thank you. I think you have helped us appreciate that one. That why do we clean the data? It increases the productivity, yeah, but also improved data quality and it reduces the errors. So you have the fewer errors in our data. So that one shows the reason why we should clean our data. Let me check whether someone has added a reaction. Yes, also for data consistency. Thank you, Clinton. Thank you, Clinton, so much. Yeah, so I think those are valid reasons, and shows that the necessity for us to clean data. And now these issues, how to do them. To combat these issues, data can be cleaned using the following SQL string functions. So these are just some SQL string functions that we can use to clean our data. Of course, we have the left, right, and trim, which use this function to select only certain elements of string and remove certain characters. So of course, a trim, if your data has spaces, unnecessary spaces, so you can trim those spaces using the trim command. The concatenate is used to add different strings together. So you can use this one if you want to add or put together different strings. You will use concat. Yeah, and I think you can see that SQL is quite easy. This is just like almost normal English language. Yeah, and it's quite easy. Yeah, and now for lower and upper, as you know, the uppercase, to change a character to uppercase or to lowercase, you use these commands. Yeah, I think you could go later on to just look on this activity and be able to do it. And I think it will help you understand more on errors that you can get while importing and exporting data, and how now the potentials and ways how to resolve those errors. Of course, it shows the potential errors that we can meet while exporting and importing data. We can have data entry errors. We can have wrong data types, wrong code, illogical data, missing data, duplicate data, broken references, data from data is not atomic, inconsistency data representation. So these are some of the potential errors that you could get while interacting with the data, that is exporting it and importing it into the database. So I think in your own time, probably you could just go through them and try even to see and interact with while you export the data or import the data, whether you meet those errors and how to solve them. I think it will help. Yeah. So there's this statement, of course, that you will constantly use, the describe statement. Probably before we move on and just get to see the function of the describe statement, maybe someone in the chat, whether you know, they probably could share, maybe someone could share what is the function of the describe statement, or what is it used for? Looking at the charts, we can share. What is the use of a describe statement in SQL? Nice. I think, well, I haven't seen anyone. Yeah, but I think we can move on. So before moving into insert statement, we'll be able to see describe statement and its function. It is used to provide a description of a specified table or view. So if you want, probably you have a table that is called country, and you want to know the fields that are there and the data types for each field. So you use the describe statement. So probably you have a table called country. So if you want to know the fields that are there and the data type for each field, we use the describe statement. So that describe, then the table, the table name, which is country. So it's either describe the table name. Yeah, so it will show that our country, it has these fields. We have the code, we have the name, we have the surface area, and this one, as the data types, we have the character. The code has a data type of character, the name character, yeah, the float, which is a data type. Yeah, so this describe statement will help us to see, yeah, the description of a specified table. Yeah, so it's so important and we need to know how to use it. Yeah, but now moving on to how to insert the data. Of course, in us inserting data, we use the insert statement as it is. So this code will help us to understand how to insert data into a table. Yes, of course, a table has different columns. We have the table, which have the table name, the columns, and now the values that are there in each column. So for you to insert, there are of course two ways. One, you could insert into the table and specify the column name, each column, probably if you have the ID here as a column name, and also probably a name, etc. of the column name, and now you specify the values of each column. And so when you insert as well, you must specify a column where the data will go. Yeah, and when you insert values, you must enclose the values with a single quotation mark, which is this one, for character or date values. So yeah, so our values, when you are inserting them, we enclose them, our character, or if we have a character or we have a date value. A character could be like a text, kama Nick, or a code like KEN for Kenya. Yeah, so that one could be a character. So for when you're including characters or date values, you insert them using quotation marks. Yeah, but when they're numbers, you don't use the quotation marks, you just insert them like the way they are, but you need to separate each value via a comma. So like for this, the column name, the first value will be on this column, the second one on the second column, the third there on the third column, like that one. Yeah, so of course there are two ways. So this first, you could insert data into all columns of the table, or you can just insert into a specific column. So if you want to insert into all the columns of the table, you just insert into the table name and then the values. So this one will insert into all the columns. But if you want to insert into a specific column, so we need, if it is a specific column, we need to define it here after the table name. So probably want to insert into column 1, column 2, column 3, and column the specific column that you want to insert. So there are two ways of inserting data. One, you insert into the whole or into all the columns. So you need, if you are inserting into all columns, you don't need to specify the column names. Yeah, but if you are inserting into probably a specific column, then you need to specify them after the table name. So like here, we insert into a table name. You say that into probably our table is called country. So say that insert into country and then specify the name here, like the country code, probably the country name, like that one, like that one. So that one is for specific, and now for inserting into all columns. Yeah, so these are things that you need to remember while you're inserting the statement. The column represent the field titles, as we say here, like column N, column 1, column 2, column 2, they represent the field titles. So this one could be an ID, it could be a name, it could be a country code, like that one. So these are things that you need to remember. Column represent the field titles. The other thing that you need to remember is that values represent the data that is being inserted into the fields. So like here, the value 11 or value 1, value 2, value 3, this is the data that now we are inserting into each and every field. Yes, so an example is here. So we have our data. Well, we have our data, our table name, I mean. We have our table name called country, and we want to insert. So of course, this country head, this table head, the code, the name, and the surface area. These are the column names, which are the specific titles or the fields that you are inserting the data into it. Yeah, so you want to insert these values. You want to add a code called NT, and it's for Netherlands entiles, and the surface area is 800. So it will go there at the bottom. It will be created as a new row. So because our table had this content up to here, and when we want to insert into this table, we insert using now this statement. We just insert into country, our table is called country, and then now we specify the values, which is and Netherlands, now the surface area. Yeah, so this one is an example that you could go through. Yeah, and Yeah, so we have this here an activity. Probably I think people could share, and before we go and see how the code could think, yeah, you could share the code in the chat, you see. So we have our table here, it's called country, and we want to use the insert statement and we want to insert the data into this table called country, and we have this specific field. We have the code, BRA, and the name Brazil, the continent South America, the region South America, and the surface area, this one. So I think someone could share a statement in the chat, the code, an SQL code that could do this, insert this data into this table. Yeah, could give you like 2 minutes probably. Yeah, I'm looking at the charts. To give you like 2 minutes, someone could share code in the chat. Yeah, to do this, to insert this data into this table. We have a table that is called country, and it has these fields, which is the code, the name, the continent, the region, and the surface area. And our data is here. So write an SQL to insert this data into the table. Are we still together? Someone can just confirm, probably via chat. I'm unable to see probably the thumbs up. Whether you can still hear me.
Yes, we can hear you.
Okay, thank you, Angela. Because I know, well, like, yeah, thank you, Ivy, as well. Yeah, thank you. I think when we practice, we'll be able to see these things are just easier. Yeah, so of course, it was simple as this, first inserting, right, insert into our table. Our table is called country. And now you just specify the values of the fields. Yeah, like BRA, Brazil, South Africa, South America, I mean, that way. So by doing so, we will be able to add another row here at the bottom of the data for Brazil. Yeah, so basically I think that is on inserting. Yeah, but I think the last thing probably we could look into is the null statement. Yeah, so this one is probably if you want to insert data into a table and you just want to use it as a placeholder. So you use null statement as a placeholder if you don't have the value. Yeah, so the value to insert there. So you use probably you don't have the values to put there. So you use the null statement. So you insert into table name the values, then you insert the null. So this one, they are just used as placeholders. Yeah, and now you can probably now insert the data later. So it helps to improve the readability and also clarify the meaning and actions of conditional statements. So the insert statement can insert a null value into a column. You can insert a null value into an int column with a condition that the column must not have a not null constraint. So if the column has a not null, that means it cannot accept a null data. Yeah, so if it has that one, then it cannot accept a null value. Yeah, so for those columns that do not have the not null constraint, we're able to use null as a placeholder. Yeah, and that one improves the readability of the data, but also clarify the meaning and actions of conditional statements. Yeah, so these are the key points about the null. A relational database management system, as the BMS, can accept optional column values. Null means not applicable or unknown, and it is different from 0 or blank. If null is in the database, it means that no value exists for that field in the database. And also null is not equal. This one actually will fascinate. Null is not equal to anything, not even itself. Yeah, so that one means that when you add probably 5 plus null, it is equals to null. And null is equals to null is false. So null is not even equal to itself. If your column is not created with a not null clause, you must put in a value when you do an insert. Otherwise, the error message will appear. Yeah, so if you have a column that is created and with a not null, so that column you must put in a value. Yeah, but those columns that do not have not null, you can use null to serve as a placeholder for the data. Yeah, so a few checkpoints. I see time is moving fast. We'll probably be able to do a practical. A few checkpoints. If we will not be able, probably I think those labs are there. We'll be able to do by ourselves and just interact with the statements. So these are checkpoints. We can have someone to unmute and read for us the first checkpoint.
Can you hear me?
Yes, I can hear you.
What are the 3 main steps for importing a .csv file?
Yes, thank you, Justin. What are the 3 main steps of importing a CSV file? You can share in the chats or probably just voice them out. They're so simple. I think as the steps that I started with are the 3 main steps of importing a CSV file. There are simple steps. Yeah, wow. I'm waiting on the chats probably to share the steps of importing a CSV file. Wow, I think since no one is sharing, probably I could just move on them first. They're here: verify, create, and import. I think I had mentioned that one. First, you need to verify the data, whether it has that is the CSV, the number of columns, whether they meet the number of the tables that you want, but also verifying the data types. And then you go ahead and create the table and now import. Just those three very easy steps for you importing a CSV file. You verify, create, and import. The second checkpoint, what are 2 ways to use the insert into statement? What are the 2 ways to use the insert into statement? Wow, yeah, I think we can just, because of time, we'll go through all of them. Are the 2 ways of inserting into a statement. And well, there's the last question being that what is the purpose of the null? And just go through them as we finish. Yeah, so because we insert first, as I had shared, you can insert into the entire probably add row with values for all columns, or you can insert into specific, that is selected columns. Those are the 2 ways of two ways to use an insert statement into statement. You can insert into all columns, or insert into specific columns. Yeah, and the purpose of a null statement, it is used to represent missing values. Yeah, so those are key takeaways. Yeah, in this lesson that is inserting. So the things that you need to know is how to import the data. So verifying it, first creating and importing it. Yeah, and now inserting into the data, you insert probably into all the columns or insert into specific columns. So when you insert into all columns, you just use insert and then table name, and then now you go to values and you specify your values. But now when you're inserting into selected columns, you have to specify them. So you say that insert, then table name, and then the columns, probably column 1, column 2, column 3, and then the values. Yeah, so the values that which is the data you include in the column. Then the null statement representing the missing values. Yes, thank you. I think that one is for the first lesson that I was to go through. Yeah, I think time is moving so fast. Let me go to the second lesson. Probably we'll be able to go through the labs and understand more how to do these things practically. Yeah, so the second lesson that we were doing, let me just go to it. Wow. Yeah, so second lesson is selecting data. So after now inserting it, we need to select data, understand how to select data from the database. So I think I can go through this very fast because I see time is moving fast. I'll go through it very fast and be able now to see how we can select data from the database. Yeah, so this is what we will learn. First, of course, demonstrate how to use the select statement. The select statement is used to retrieve data from the database. Yeah, but the other thing that we'll be able to do and learn in this lesson is to identify the correct syntax of a select statement and demonstrate how how to select data from certain columns or from all columns. Yeah, and the last thing that probably we'll check in is demonstrate how to use where clause to request that only certain rows from a table that you require. So if probably you want certain row, you do not want to all the fields, you can use the where statement. It helps us to select the certain rows that we want. So we can go to the select statement. When using select statement from a database, you use the select statement. When you want to select data from a database, we use the select statement. And how it is used. You just select, then probably the columns. So you want to select the column with ID. You want to select the second column with the name and the country code from our table is called city. Yeah, so this is how we will select this data and be able to display it. Yeah, I think I could just show in my Vocalium. I hope it is running. Let me just open it. Yes, it's opening. I think we can continue. Yeah, so this is how you can use the select statement. You just write select ID, probably the column name, the different columns that you want to extract data, the data that you want to view. Yeah, and now the from the table name. So you need to have this statement probably to select data from that table. Yeah, so this is how it works. Yeah, so you remember the where statement. So if you want to select now, to narrow down to specific row, so you add the where clause. So like here, we are selecting the ID, the name, and the country code from our table, which is called city, where the country code is BRA, which is for Brazil. So we use that from the city table, get all data, which our table has ID, has name, has a country code. And our table is called city. And we just want to select the data at the code where the code is BRA, not the whole data. So the where clause comes in to help us do that. Yeah, so this is how it works. Yeah, so I think I can run my instance. But yeah, command host.
Nicodemus.
Yeah, it's not responding. I think I will check later. I don't know what's my problem with my, yeah, but yeah, I think, yeah. Connect session manager, connect. Yes, as it runs, I think you can continue as we wait as it runs. So this is how this works. So the where statement helps us to select specific row data from a specific row. So this one now can narrow down and be able to get the data that you want from a specific row using the where statement. Yeah, so this is just an illustration to show it at work. So we have this table that has an ID, a name, a country code, and a district. And you want probably to select the ID, the name, and the country code, excluding the district from this table. Yeah, so we will select our and now there use our select statement and put our columns. I mean, so the first column being ID, the second one being name, and the country code, and we exclude the district. And now we are selecting from our city table. So our table being here. This is now how it will display. So it will just select the ID, the name, and the country code, excluding the district. Yeah. Let me change to sudo su. Yeah. Cd, change to the root user, and we cd into our home. Hope it is EC2 user. Hoping it's that way, that directory. Yeah, and then we are given here how to connect to our, let me just move here, how to connect to our database. We have the AWS have provisioned for us a database. Probably, I think you'll follow through these labs and be able to see see it. Yeah, so we can connect to it. And now we are in our MariaDB. So for us probably to view the available database, we can use show databases. Yeah, and able to see we have our database called world. So I don't remember how to move to that database. Yeah, so we have here a database. I think we can continue even as then we'll come back and appreciate, see how we can use the different statements to view the data. Yeah, moving on. So so this is, I think we have seen the syntax. This is the syntax of our SQL. So we use the select and now the column name, probably column 1, column 2. Yeah, and now from the table, so the table name, and where now you can insert here a condition where probably the ID is this, where the country code is this. So this one, the where statement helps us to insert a condition, but also you can use a group by statement. So we can group by probably the column name. So we want to group with column 1, column 2, and column 3. And having, so this one you can narrow down also now using having statement. So from now our group, we can insert a condition here and now narrow down the data, and the order by helps us to order probably in ascending order or descending order, or in the order that you want. Probably if you want to order by, you order by now you say that order by the column name, and you can there insert all those requirements. So these ones are optional. So depending on the data that you want, the where, the group by, the having, the order as optional, but this one is required. The required clauses is the select and from. So if you just use select column name and this one from this table, you're able to view the data. But sasa now, if you to view specific ones, so you use the column, the where statement, the group by, having, to narrow down and be able to use the data that you get the data that you want. Yeah, so an example is here, of course, just continuing to explain how to use the select statement to view the data. So yeah, this one I think it explains what we have shown up there. Yeah, so the different ways to select columns. There are different ways to select columns. So of course there's you can just use select. That is, if you want to select a single column, you select the column name from the table. That one helps us to select a single column. But if you want to select a single column and optional columns, you select that column, which is column 1, and now these are optional. Can include them or not. But if you include them, you use the brackets, the corner brackets, to select those optional columns. Yeah, but if now you want to select all the columns, you use this star. So select star from table name. So this one will be able to select all the columns and display to you all the data that is in the table. Yeah, I think this one just an explanation from up there. This is an activity I think you can go through at your own time and just be able to see, to interact with the select statement. Yeah, and understand them much and much more. Yeah, so of course the optional clauses, as I said earlier, so there's the where, the group by, having, and order by. Yeah, so these statements helps us to narrow down and get the data that you want, the specific data that you want from the table. Yeah. So this is just a demonstration here. So you can say that you want to select an ID, a name, and country code from our city table where the country code is BRA. Like that one, then it will output the specific. So this one you see we have narrowed down to Brazil alone. Yeah, so we see the data for our ID is 206 and the name is Sao Paulo. I mean, not Brazil, Sao Paulo, and which is, well, the country code is BRA for Brazil. Yeah, so this one narrowed down, you're able to get the specific data for that row. So that is now the importance of the where statement. It helps us to get specific data from the table. Yeah, but also we can group by, which is an optional clause that you can use. So the group by this is how it is used. So if you want probably now to group the data. So we want to select the continent, and now, of course, the count, this one shows that all the count, it will show all the continent from that country, and now you want to group by continent. So it will output the count, all the countries. I mean, the count will show that all the countries are there. So like in Africa, we have 3. In Europe, we have 1. In North America, we have 2. Yeah, so we see there we're able to group by the continent. So all the continents that we have in Africa, the 3 in Europe, that were in North America, 2. So the group by helps us to group them. So you can see it here. Yeah, so you have different continents like North America, Africa, yeah, and the name now of the different countries that are there. So you have Kenya, we have Madagascar, we have Tanzania. So you see that like there are 3 in Africa. So the group by helps us to group, like for Africa, we have the 3. For Africa, we have the 3 countries there. So you're able to group by the continent. And in North America, we have like 2. In Europe, we have 1. So the group by helps us to group the data into, so depending on if you want to group probably by the continent, yeah. So I think like for this table, we can only group probably by continent. Yeah, so because a continent can have different datas. So now we say probably see all these one, you have North America and North America. North America has Canada and United States. So you can say that you want to get the data for North America. So we use group by, and we be able to get that data. This is an optional clause and shows how to use group by. Yeah, and of course, the count, having count is 1. So we can now narrow down and use having statement. Yeah, so of course the group by groups the data into the different groups that you want, but now we can also narrow down and use the having statement. So we have probably now we have grouped our data into the different continents. So we have the Africa has 3. We have North America has 2. Europe has 1. So we want to group and display the data where this one says that where the count having count, now we can use the having statement and say that the count is greater than 1. So this one means if you understand code, count being greater than 1 means that where this count as a variable says that it counts. So where the number of the countries is greater than 1. So that one we see we have Africa and North America. So it will be able to display it will display now Africa and North America because they're the one who they have a count that is greater than 1. But if it could have been probably where count is equal to 1, it will have displayed now Europe, because having count, yeah, the count equals to 1, it will have displayed Europe. Yeah, so I think that one is how you can use the having by, order by, yeah, and yeah, this one are optional. So depending on what you want, so able to use where, group by, having, order by, yeah, and get the specific data that you want. Yeah. Yes, of course, I think while you code, of course, I think comments are necessary. Yeah, so that is now for the people who will see your code later. The comments helps them understand the code, what the code does. So I think also in SQL, comments are used. So I think even as you write your code, so it's necessary probably now when you were at work and umetoka umeenda to a different job and you had a code. So for the other people to be able to understand, it's a good thing to include comments into your code. And so that's why now, of course, it's necessary to understand also how to write comments in SQL. So there are single line comments. For single line comments, you start with a dash dash. So of course, it will just understand that is a comment when you start with a dash dash. So you say that dash dash display the table structure. So that one, table structure will be displayed by this code here, which is describe city, to display the structure of the city. And if it is, so for the inline, that is, you can put the code at each line, or probably a single comment just above the code. So you start with a dash dash. But if it is a multi-line comment, like this one, when we have commented this code, when we start, we use this sign here, the slash and the asterisk. Yes, the slash and the asterisk. It is used now for multi-line comments. Yeah, but for the single and inline comment, you use the dash dash. Yes, checkpoint questions probably. Let me read the charts, C5 charts. Oh, I think it doesn't concern me. And Nicodemus are dealing with a team with this topic. Wow. Oh, I had not seen that one. Yeah, but I think now probably since I have gone through the theory, yeah, the other team could go through the practical bit. Yeah, because I think time is far much spent. So yeah, because I had just opened the vocarium, so I think the other team could go through the practical bit and just demonstrate the statements and how to use the SQL statements. Yeah, I think because for us time does not allow. So these are the checkpoint questions. How do you select all columns in a table? Yeah, someone could write in the chat, how do we select all columns in a table? That is simple. How do we select all columns in a table? You use the select with an asterisk sign. Thank you, Clinton. Yeah, that is it. What are 3 ways to provide comments in your SQL code? 3 ways to provide comments in your SQL code. Yeah, thank you, Gideon. You use select and an asterisk. Yeah, question 2, what are 3 ways to provide comments in an SQL code? Yeah, majibu zinaweza kuja in the chats. The 3 ways to provide comments. I've just, yeah, inline. Thank you, Angela. Inline comments. Yeah, and the other one, the 2 remaining. Have the inline comments. You have the single line comments, multi-line comments. Yeah, thank you, Frank. Thank you, Frank. Yeah, Msembi. Yeah, of course, now that one, it should be the dash dash mbili. It shows it is used for the inline. Joking for them. For the inline, you use the dash dash, 2 dash dash, and then at the start for the inline, but for the multi-line comments, you use the slash and the asterisk. Yes, what are 2 required clauses for the select statement? What are 2 required clauses for the select statement? 2 required clauses, I think I'd mentioned that one. Can send. What are 2 required clauses? From, yeah, from, because now from then the table name. Thank you, Gideon. That one is a required clause. The first one, select. Thank you, Clinton and Felix. So we have the select and the from. Yeah, those are the 2 required clauses that we use. So these are our key takeaways So you can use the select statement to select one or more columns from a table. In SQL, you can use the where clause to apply a filter. So the where clause is used to apply a filter. Yeah, so yeah. Yeah, that is comes at the end of our lessons. Our two topics. Thank you so much. I hope probably the next team will be able to demonstrate. Yeah, because I think I have used a lot of time. Yeah, so that now the next person can be able to present and share. Thank you so much. Probably I can take back to Angela. Thank you.
Thank you, Nicodemus, for your presentation. That was well done. So we're going to have next Roy presenting. Roy. Okay, I'm not seeing Roy from the participants. I think he's absent, so I'm going to take over that. But in the meantime, I think we can have Belinda doing her presentations. Belinda, are you ready? Belinda, hi.
Let me call her, Angela. Just a second.
Okay.
Hi guys, can you hear me?
Hi, Belinda, we can hear you.
Okay, so I'll take you guys through the next presentation in a few. Just give me 5 minutes to set up.
Okay.
Are you able to see my screen?
Yes, we are.
Hi everyone. So I'll be taking us through how SQL helps us manipulate and organize data using functions and some key clauses that make queries more powerful. So functions are like little tools that help us quickly process, clean, or calculate data without writing long formats. Functions perform operations on data and return a value. There are two major types of functions, including built-in functions as provided by SQL and user-defined functions as created by users. These are the most commonly used types in SQL. Let's see examples for each. So the first function I'm going to talk about are the date functions, which handle dates and times. And then there are aggregate functions, which perform calculations on sets of rows. And then there are also string functions, which manipulate text values. So the date functions are useful for reports, like finding out how many days passed between two events or checking upcoming dates. So for example, the current date function returns today's date. And then the next one, date add function, order by date, interval 7 day, add 7 days. And then the last one on the slide, dated diff, end date, start date, returns the number of days between two dates. So that was the first function. And then now we have aggregate functions. These are perfect for analytics, like calculating total sales, averages, or the highest scores. So examples of aggregate functions include count, which counts rows, and then there's the sum, just as its name suggests, adds up values, and then there's the average, just as its name suggests, finds the average of a total. And then there's also maximum and minimum functions, which find highest and lowest, which find the highest and lowest. And then we'll move to string functions. We use string functions to clean up or format text. For example, standardizing customers' names or merging columns. Examples of string functions include, like, for example, if you want to return hello in uppercase, you will use upper hello and it will return it in uppercase, and the lower function will revert that into lower cases. And then if you want to return, for example, a name, you concat first name and the last name to give you Belinda Ochieng. And then if you want, for example, the number of characters, you'll use length. For example, Kisumu, which has 6 characters. And then from that, I'll move straight to section 2 of my presentation, which is organizing data. So first, I'll start by sorting data with order by. This helps us to view our data in an organized way, maybe to see top performance or latest transactions first, just as the name suggests. So it's used to sort query results. For example, select from students, order by grade, descending order, will return the grades of students in a descending order. And if you were to use ascending order, it will return the grades of students in an ascending order, meaning from the top to bottom. And this is normally the default. And descending is from bottom to lowest. And then we have also grouping data with group by and having. Group by works like putting data in boxes by category. Having helps us filter which boxes to keep. So group by groups rows that share the same value. Having filters results after grouping. For example, select department whose average salary from employees grouped by department having an average salary of 50,000 will help us group employees who have an average salary of 50,000 from a particular department. And then section 3 of my presentation involves retrieving data from multiple tables. And I'll start with combining results with union. This merges results vertically, combining different data sets into one list. So combined results of two select statements must have the same number of columns. That's very important to note. For example, if you were to select from a city, select city from customers, union, select city from suppliers. It means we will combine customers from a specific city and combine them with suppliers from a given city. And then I'll go straight into joining tables. Joins link related data across tables. For instance, showing each customer with their corresponding orders. So we have a number of joins. For example, inner join, which only matches records. Left join, from left plus matches, and the right join, all from right plus matches. For example, if you were to select customer's name, orders, date from customers, inner join orders on customer's ID and customer orders. So to summarize what I have talked about today are SQL functions. SQL functions make queries powerful. Aggregate and string functions for cleaner results. Order by, group by, and having for structured data. Union and join connect multiple tables. And that brings me to the end of my presentations. Thank you so much for listening. Do you have any questions? I take that there's no question for me. So I came up with this presentation by myself, and I checked on the Canvas for some insights, and I might have skipped some, so make sure to also counter check with Canvas to see anything that I missed. Thank you so much for your time. I welcome back Angela.
Well, thank you, Belinda. I like it. Short and sweet. Thank you. So next we are going to have Leonard again for his last presentation. And then I'm going to take over. Leonard, are you ready? Leonard, are you ready?
Angela,
Mm-hmm.
as we are waiting for Leonard, I
Yeah.
have a question. I have a question for you.
Mm-hmm.
First, let me know. You people, kwani you knew each other before the group?
No?
You're setting the bar too high. You even have a news presenter in your group. Like these bars, my where my bosses, if they come and hear you people presenting, to make us a kazi, we do not
Yeah,
have work.
it comes with the name.
Kabisa,
It comes with the name, Team Fire.
jobless corner kabisa, kabisa.
The team is well organized.
Where? Let me tell you, Angela, itabidi tumeanza kutafuta kazi. Benson, I agree, I concur with you. And people, I need to ask, do you know where I can get a whole garden of flowers? I need a whole orchard for this team. 1, 2, 3 flowers. Nanichokesha kuwapea kamoja kamoja. The amount of times I'm clapping. Eh? People are presenting with passion. Hey, very nice, very nice. So
Thank you.
karibu. So congratulations. Let me see if I can get a hold of Leonard as we wait. Or maybe you can start and then he goes. I don't know.
Also, I had a question. Are we also doing the database services module today?
Which one? Introduction.
Yeah, the other module, service module.
AWS database services.
Yeah.
You're just supposed to do an introduction. Just an
Okay.
introduction of the database services that you have in AWS. So that now
Okay.
from tomorrow we can start on RDS and Aurora.
Okay.
Leonard ni kama ameshuka kwa mto kukunywa maji.
Okay, I can take over. So you can see my screen, right?
Yes, we can. Yes, we can.
Okay, so I was not prepared to do this presentation. However, I'm going to try my best. Okay. So this is performing conditional searches in the database. So we're going to start with simple search conditions. Yeah. So we've seen some of them from what my team members have been presenting. So the first one is the use of select statements to retrieve data from database tables. Adding a where clause to a select statement limits the data that is retrieved from a table. The where clause applies a search condition to each row of the select statement. The search condition uses operators to specify the data that the query includes. So you can use the select and where together to search for the various things you want to access from the database. Yeah. So the select statement has 5 main clauses. From, that is what Nicodemus has just touched on. The where clause, group by clause, having clause, order by clause. The where clause is used to filter the data that the query returns. The where clause sets up a search condition that uses a logical test to decide whether a row should be included in a query. Search conditions compare two values by using an operator to test whether the search condition is met. Because you're looking for a specific thing or you're searching for specific items, so it has to analyze whether whatever you've written as your statement has been verified, has been allowed, okay? So if the search condition is met, the query returns the data items from the table. So if the search is complete, the queries will be shown from the table, right? So this is an example of how to use the where clause. Criteria to search for selected values in the table. So we have the first query there, select continent, surface area, population, GNP from this country table right here, this one here. Select continent, this continent, surface area, this one, population, this, GNP, from the country table where name is Ireland. Okay, so the output will be all the countries from the specific value, Ireland. And the tables columns will be continent, surface area, population, GNP. Right, that's going to be the output because that's what you've specified that you want using the where statement. Okay, that's what that is. We have operators. So here we've seen one of the operators, that is the equal sign right here where name equals Ireland, but let's get more in depth about operators. So types of operators. 3 types of operators are used in such conditions. Arithmetic operators perform mathematical operations, as from the name, arithmetic. Comparison operators compare values between data items. Logical operators used to build compound conditions. These operators can be used in select, insert, update, and delete. So we've learned about select, insert, update, and delete statements previously. So these operators can be used together with them. And the operators are arithmetic, comparison, and logical. Yes. Okay, so we start with arithmetic and comparison operators. So arithmetic is just the same mathematical operations that you do. So we have addition, that's the addition sign, subtraction, the subtraction sign, but now it's an SQL operator. Don't confuse the two, right? And then we have multiplication, this is an asterisk, division, the slash, modulus, which returns the remainder, the percentage symbol. Okay, yes, those are the arithmetic comparators. No, arithmetic operators. And then we have the comparison operators. These are used to compare values, right? So we have the equal sign, which is now an SQL operation. It compares two data items to see whether they are equal. And then we have the not equal, which is an exclamation mark together with an equal sign. And also you can use the greater than and less than symbols. So you can use one or the other to represent not equal. This compares two data items to see whether they are not equal. We have the less than sign right over there, compares two data items to see whether the value of the data item on the left is less than the value on the right. Yeah, so it compares the two if it's less than, kama iko kidogo, if it's smaller. And then we have less than, equal to. I think this slide is wrong right here. So it's supposed to be less than or equal to. It compares two data items to see whether the value of the data item on the left is less than or equal to the value on the right, or equal to the value. Yeah. So that's the sign. Take note of that error right over there. And then we have the greater than sign. This compares two items to see whether the value of the data item on the left is greater than the value on the right. So these are normal operations that we know of, but it's better to get an understanding of them. The only one that is different is the not equal operation. Then we have the greater than or equal operation. It compares two data items to see whether the value of the data item on the left is greater than or equal to the value on the right. So I think we all have an understanding of arithmetic operators and comparison operators, right? Okay. So the not equal operator has two options. That's what I've talked about. Which operator you use might be your personal preference, or it might be formally defined according to the company's established coding standards. So whatever you use is different depending on the company or your choice, right? So this is an application of how to use the arithmetic operators. So you have a query right over there. Select name, and then the values that you want is life expectancy and comma, life expectancy plus 5.5. So we've said the plus is an arithmetic operator to add values on it, right? So it's going to add 5.5 years to each life expectancy value that is displayed in the output from the country table where GNP is greater than. This is a comparison operator, right? It's used to select values that are greater than, right? So the output must have life expectancy and life expectancy, which has been added to 5.5 years from the country table, and it has to have GNP, all which are greater than 1.3 million, right? Yes. So the output, as you can see here, is the name, the life expectancy, and life expectancy plus 5. You can see that clearly it's been added to here in the new table there. Okay, so we have the next arithmetic operator, the subtraction arithmetic operator. So it's the same function as the addition, just that it subtracts, it removes from the values. So we have a query here, select name, continent, population minus 350,000 from country where name is equals to United States. Is equals to is a comparison operator, which is usually equal to, meaning equal to, right? So the output must have name, continent, population, and population less than 350. So it will perform that for you. It will subtract 350,000 from the population value, okay? Then it will only output United States because you specified you want all values only equal to United States. So that's the output right over there. The explanation is right there. Then we have the I hope I'm not going too fast, right? We are all together. Yes?
Yes, we are together.
Yes, yes.
Okay. So multiplication arithmetic operator. We have the query right over there. Select name, continent, population times 1.15 from country where name is equals to Malta. This is used to multiply, and whatever you're multiplying with has to have a 1 preceding it. So from the explanation right over there, the arithmetic operator increases the population by 15% and displays the result in the output. So whatever value after the 1 point, that's what you're going to increase the population by, yeah? So the output has to have name, continent, population, and another tab for population multiplied by 15%. Name is equals to Malta, another comparison, again, a comparison operator. So it has to only output values that are equal to Malta. So nothing else, all values Malta. So that's the output right over there. The next is the division operator. The arithmetic
okay, no, query is select name, region, population, surface area, population divided by surface area from country where population divided by surface area is greater than 3,000. So this is a very complex query whereby population, there's a new tab where population is divided by the surface area, and also it has to be greater than 3,000, whatever output is going to be shown. So that's what they are explaining there. So the output has to have name, region, population, surface area, and the population divided by surface area. That's the output that you're seeing here. And it only shows values right over here in this tab of population surface area. It only shows values that are greater than 3,000. Yeah. Okay, so that's it. That's the explanation right there. And then we have the modulus arithmetic operator. So we have a query. Select name, population, surface area, population divided by surface area, population, the modulus sign, and then surface area from country where name equals to San Marino. So the modulus operator calculates the remainder of the population divided by the surface area and displays the remainder in the output. Yeah, so the output has to be specifically San Marino because that's what the comparison operator equals to has assigned to it. So it's going to have name, population, surface area, population divided by surface area, and population, which has that modulus surface area. So that's the output right over there. Okay, we are together. And then we have logical operators. So first I said that there are three operators, right? Comparison, arithmetic, and logical. So now we're in the third form of operators, that is logical operators. So these are the common ones. We have and, or, in, like, between, not. So what is and? And joins two or more conditions in a where clause. All conditions must be true for data items to be affected by the SQL statement. So anytime you add the and operator, it has to have both whatever you specified in the output. Yeah. Or joins two or more conditions in a where clause. At least one of the conditions must be true for data items to be affected by the SQL statement. So or is optional. You can pick one or the other. Yeah. In used for matching on multiple data items in a single where clause by using a list of conditional values. So this is for multiple data items for a list of conditional values. We'll get in more detail about in the coming slides. Like used for matching on multiple data items in a single where clause by using partially matching conditional values referred to as wildcards, denoted by the underscore or the percentage sign. So even like, we'll also get into more detail in the next few slides. You'll understand it better in the next few slides, but it's also used for multiple data items. Between is used for matching on multiple data items in a single where clause by specifying a range on matching conditional values. So between is for a range. Between is quite simple. We use it most of the times. So between is also for multiple data items. Not is used to reverse the effect of in, like, and between operators. So and or, is for both. And is for both, or is for either. In, like, between is for multiple data items. Not reverses the effect of in, like, and between. We're going to get into more detail about in, like, and between in a few slides. Okay. So and logical operator, applications of where it's used. So we have a query. Select name, district, population from city where country code is equals to IND and district equals to Delhi. So clearly we have the logical operator and here. All where clause conditions must be true for and operation to take effect in the SQL. So all of them have to be implemented. Yeah. So as you can see here from the output, we have district and we have population. and we have Delhi. All of them that have Delhi are in the output. Yeah. Okay, so that's what this query uses AND operation to return items for cities in India. Oh, that's what IND meant. Okay. Whose district is called Delhi. Oh, yeah. So a city must meet both of these conditions to be included in the query list. So it has to be a city in India and it has to be a district called Delhi. So that's why you see all of them have Delhi in their names. Delhi, New Delhi, Delhi Cantonment. Yeah, so we go to the next operation or logical operator. We have the query select name, district, population from city where district equals Delhi or district equals to Punjab. The logical operator here is or, right? So at least one where clause condition must be true for an operator to affect an SQL statement. So the output has to have Delhi and has to have Punjab, right? So all these are districts, Delhi and Punjab included in the output, because either or, it doesn't have to be both, it's one or the other. So both are included in the output. Yeah, so a city must meet one or the other of the district conditions to be included in the query result. Okay, so for example, this district only met the where district equals Delhi SQL, whereas this Punjab Ludhiana, it only worked on district equals to Punjab statement. Okay, then we have the in logical operator. So this is where we get in-depth information about understanding the in logical operator. So the query, select name, district, population from city where district is in, where district in Delhi, Punjab, Kerala. So the in operator returns rows that match the listed values. So we talked about a list when I was explaining about in. So the output must include values from the specified list right over here. So as you can see here in the output, there is Delhi, there is Punjab, there is Kerala, and again Punjab. So it has given us all the values that are in district, the specified list, okay? So it takes multiple values from a defined list. That's the in operator. Okay, the query result set will include any city with a name that matches one of the district names in the list. So any that matches from the specified list. Okay, then we have the like logical operator. The query select name, district, population from city where district like West. The wildcard character, that is the percentage sign, is used with the like logical operator to substitute for one or more characters in a string. So all it has to have is West. You don't know. So for example, when you're typing this SQL, you don't know the continuing statements. You just want anything with West, right? So that's what the output gives us. West Australia, West Flanders, Western Cape, Western Mindanao, Western Visayas. So the query uses the like operator with a wildcard to return data items for cities whose district names start with the name West. So this wildcard, you can use it before, you can use it after. The rest of the name consists of any number or type of characters. So for example, you see here it's West and then space, Australia. And then this other one is Western, right? So like is used for any value that you specify from the start of the value that you specify to anything else. Yeah, we are together. Thumbs up if we are together. Okay, nice. So we can go to the like logical operator using the underscore wildcard. So we have a query, select country code name from city where country code like B. The wildcard, so the previous wildcard is the percentage sign, but now we are using a different wildcard that is the underscore, right? So the wildcard character is used with the like logical operator to substitute for a single character in a string. So from here, we've seen that it has any value that's B. So the country code has to have any value that's B. So here in the country code of the output, you can see B, 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 but these left and right characters are different. They don't match. So you specify only a single character, but for the percentage sign that was used previously, you specify any number of characters. For the underscore, it's for a single character. Yeah, that's the difference, but they're used in the same way with the like operator. We have the between logical operator. Select country code, name, district, population from city where population between 500,000 and 505,000. So this is a range from the specified values. So between is for a range of values. So the output must have any value within the specified values that you've entered. So all these values you see here are within that range, right? There is none that is above. Yes, so that's the use of between in SQL statements. Then we have the not logical operator. Query, select name, district, population from city where country code equals can and district not in Ontario or Alberta. The not while keyword can be used with in, like, and between, as we said in the previous slides. It can be used with either in, like, or between, because in, like, and between are for multiple values, right? So if the output has every other value except the ones that you've specified, Ontario and Alberta. So from the values you see here in district, there is no Ontario specified and there is no Alberta specified. So that's what the not operator is specifying, right? Okay, then operators can be used in flexible ways. So we have query 1, which uses the AND operator and the not in operator. And then query 2, which uses the AND operator and the, what were these? Logical operators, the signs meaning not equal to, right? So these statements mean the same thing, but you're using different values, right? No, this was a comparison operator, this. And this is a logical operator. Not is a logical, and these signs meaning not equal are comparison operators. So they are the same, but you can use it whichever option that you want. Then we have operator precedence. SQL operators are evaluated in a defined order in SQL statements. So evaluated first, we have operators enclosed in parentheses. What are parentheses, guys? Can you show me in the chat parentheses signs, symbols, the symbol for parentheses? Thank you. Then we have evaluated next. After the parentheses, we have operators for multiplication or division, operators for addition or subtraction, comparison operators, not operators used with in, between, and like, and operators, or between in and like operators. So this is the sequence of how the SQL evaluates the statements. So first is the parentheses, then we have multiplication and division, then we have addition and subtraction, and then operators, that is the logical, comparison, and arithmetic, others now. And then we have the not operators and the and operators and the other ones now, okay? So that's the precedence. By default, SQL operators are evaluated in a defined order in SQL statement, the order that we just said. You might need to have a search criteria evaluated in a different order. You can use parentheses in the where clause to force your criteria to be evaluated in a different order. Okay, so it can be evaluated in whatever way that you wish. Using parentheses to enforce operator precedence. Oh, thank you, Gideon. Yes, Gail, this is like BODMAS again in words form. Yeah, so that's the sign for parentheses. Naona tuko wengi, we don't know the sign for parentheses, but now we know. So using parentheses to enforce operator precedence. We have different queries. The query returns data with country code, PAK, and district Punjab or district Sindh. So we've already learned about the AND operator over here. The AND operator, which Punjab needs to be in the list. It means it has to be there, both the country code and, is it country code? No, only Punjab has to be there, or selects either. Yeah, so that's what the output right here outputs. The query returns data items with country code PAK. So it has a country code PAK, okay? And then this other query, an attempt is made to revise the query to exclude cities with populations less than 1.5 million. So we have district Punjab or district Sindh and population greater than 1.5. So the output must be anything above 1.5. So anything less is not in the output. All right, that's what the statement right there is showing. Okay, the first query lists all data items with country code PAK and a district of either Punjab or Sindh, because it has the OR statement right over there. The second query adds an additional search condition. The search condition was intended to limit the result set to only those populations with more than 1.5 million. However, adding this additional condition to where clause did not produce the desired result. Yeah, because some of the outputs shown here are less than 1.5, right? Yes, some of them are less than 1.5, like Punjab, Rawalpindi, and Multan, right? This unexpected result happens because by default, and conditions are applied to the query before all conditions. So R is precedence, it's preferred than the OR. Yes. Therefore, the second query still returns rows for Rawalpindi and Multan, both of which populations smaller than 1.5. So by default, and are applied before the OR. And only in the statement here, OR is the one that has the AND operation for population greater than. That's the only one that has. So this population did not apply to Punjab. This population statement right over here did not apply to district Punjab. It only applied to the OR district Sindh. Okay. So the next slide shows how to fix the issues. This is the result. Using parentheses. If you use parentheses, all the statements that how you intended the statements to produce the output will be achieved. The result will be achieved. So as you can see here, our final output has population greater than 1.5. Yeah, this is our previous statement. This is the correct statement right over here. It only shows the ones that are greater than 1.5, population greater than 1.5 million, mainly because you use the parentheses, all right? Wherever you want to include, you include it in the parentheses. Okay, so that's what the explanation is. Can go to the next. Using parentheses to enforce operator precedence. Select, as you can see here, this one is also like the one that we did right over there. It doesn't have the parentheses, but this other one has the parentheses. So only Sindh will have a population of greater than 1.5. But in this one, both Punjab and Sindh will have a population output of greater than 1.5. So we can go through this. In the first query, all the data items for Punjab are included in the query. Yes, all the items, because you only specified that you want equals to Punjab. You didn't specify that population needs to be greater than something, right? So all queries with Punjab are included. This result occurs because population size never applied to cities with a district of Punjab. In the second query, the query results included all data items for Punjab that have 1.5 million people, greater than 1.5 people. The results also included data items for Sindh that have more than 1.5 people. So that's what I have explained. If you'd like to do the activity, it's there on Canva. You can take the time to go through it and understand the content further. Okay, alliances. This is a new one. Okay, so What are aliases? We did talk about this previously, but I'm going to touch on it. An alias is used to assign a temporary name to a table or column within an SQL query. Alias exists only while SQL statement is running. Aliases are useful for assigning names to obscurely named tables and columns. Aliases are also used to assign meaningful names to query output that uses as arithmetic SQL operators. Aliases can be specified in SQL statement by using the optional AS keyword. If spaces are designed in an alias name, the alias should be defined in a quotation marks. Yeah, so we use an as keyword. That's the word to specify an alias. So an example application is this one right here. Select name, life expectancy plus 5.5 as new life expectancy. So this value of life expectancy plus 5.5 is going to be written as new life expectancy. That's the alias you've given it, right? So as you can see from the output here, we only have three outputs, three columns, that is name, life expectancy, and the new alias that you created, new life expectancy. That is life expectancy plus 5.5 specified here. So because you use the as keyword, that life expectancy plus 5.5 is not going to be used in the output. That's what you can see there. Hope that is clear. Including spaces in alias. So if you want to write the alias in a readable, human readable form, you can include spaces. But when you want to include spaces, you have to use the quotes marks. The quote signs. This one's right over there. So that includes the spaces right over there. As you can see, this new table, the new life expectancy is not just one word, it's separate words. New is a separate word, life is a separate word, expectancy is a separate word. So that's how you can use spaces. Now we have null values. One of my team members looked into this, but we're going to see an overview. Databases uses null to represent the absence of a value for a data item. Because they have no value, null values cannot be compared to each other by using typical comparison operators. Because they have no value, null operators are not equal to one another. Use is null and is not null when working with null values and where clause. So when you're using the where clause, you're searching for a specific record or a specific file. So to find files with nulls, you use the is nulls. If you want to find values that are not null, you say is not null. That's how you specify it, right? Tables can be designed so that null values are not allowed. Whichever way that you want to apply your tables, you can have the null or you can decide not to have null. So we have an example of how null statements are applied. So you are expecting the output to have name and life expectancy from your table called country, where life expectancy is null. So it outputs all values where life expectancy is none. And name, not like that one, island. So inside the name, it has to have something island, right? So those are the outputs. It shows all values that have null, right? So countries with no data for life expectancy will have null values for this column in the table. Using null operator as a search condition, this query returns data items for countries that do not have values for life expectancy. That's how you use the null statements, is null and is not null. So we have another example. Null values can affect query results. So as you can see here, we have three tables, name, life expectancy, and life expectancy plus 1. Adding 1 to the life expectancy column still returns null because there is no value as we've specified. Null means the absence of a value. So if you add plus 1, which is an arithmetic operation, it still leads to none. So the output is still going to be null as shown there. That's the explanation right there. And we have a discussion What is the purpose of null values? I believe we talked about these null values and we all understand what they are and their purpose, right? So I can just go over them and have the checkpoint questions. What is the purpose of a condition in a query? Type in the chat your answers. What is the purpose of a condition in a query? What is the purpose of a condition in a query? Why would you need a condition in a query? To filter and specify which data to include in the results. Thank you, Nicodemus. Ivy, to filter. Yes, thank you, guys. Yes, you can use conditions in a query to filter your search results. Okay, the other question, why should you use aliases in SQL? Why would you need aliases in SQL? I've just talked about them. We know what aliases are for. Thank you, Gail, for assigning names to obscurely named tables and columns. Daniel is saying for naming. Yes, that's right. Thank you, guys. It's for naming. Aliases are often used to make column names more understandable. If you want an output that is more understandable to you, you give it an alias. That's what that is. We have the key takeaways. A search condition. So what we've learned is about a search condition, that is the where clause, the operators, the arithmetic, comparison, and logical operators. We've also learned about naming aliases. In some situations, aliases make your SQL statements simpler to write and easier to read. We've also learned about null values, require special handling in SQL statements. Null is the absence of a value. Use is null and is not null in queries. And that comes to the end of my presentation. Thank you, Musembi. Thank you. I think I'll hand over to, is Leonard back?
Yes, I'm back. Sorry for the absence. Yeah.
Yeah, it's okay. So I think you can do your final presentation, if that's possible. Is that possible?
Yeah, I can proceed with the final presentation about the joins. Yeah.
Yeah, after you, I think we'll have Brian. Brian, please get ready to also present after Leonard. Thank you guys for listening and participating.
Yeah, do applause, Angela. Great work. Yeah, good work. Good work. Yes, I think my audible.
Yes, I can hear you.
Awesome. Great stuff. Thank you for the session. Had some issues to handle here, but I'm back. So what I'm going to talk about is retrieving data from multiple tables. Yeah. So what am I going to talk about now? So the module overview, what we're going to talk about is learn how to combine data from different tables in a database. Yeah. So the two main techniques here we're going to see is the union and the join, whereby you stack results, that is the union. Stack results from multiple queries. The join, you combine the columns from related tables. So yeah. So what this module covers is combining query results using union operator, said about it, retrieving data by joining tables, then understanding how relation database connect information. this is something I added, is that real data is split across multiple tables, whereby like in the previous examples that I was talking about, you can see from, for example, from another scenario, you have like patients, appointments, doctors, you have maybe departments, yeah. So how do you, so there is a need to combine this information to answer like this next question. For example, somebody may want to understand how many patients were interacted with different doctors, or how many appointments per patient, so stuff like that. So yeah, that's what we're going to understand and talk about. So the union operator, it's combines results from two separate queries used across vertically. For example, show me all contracts here. For example, both patients or staff. So yes, this is just a deep overview of both the join and the union. Then you say, for example, show for the join, combine columns from related tables. So you link data through four keys, the one which I had talked initially. The parent and the child key, or the parent and the child components, yeah. So for example, show patient with patient names with the appointment dates, yeah. So here the patient names, you can refer to them as the parent. Then the appointment dates, you can then link them and call them like child, yeah. So yes, terms to master, that is set operators that combine both. I mean, combine query results, that is the union intercept, except union, that is stack results. Yes, so this is just showcasing what we are going to talk about or see. So set of operators, so what are they? A simple explanation is they combine the results of two or more select queries into a single result set. Think of it like, for example, you have two piles of cards. Then the set operators determine how to combine them into one pile. Yes, that is a simple start. Then there is three main set operators. You have the union, that is combined results and removes duplicates. Okay, sorry again, technical issues. Today's the day, my guys. So yeah, I was talking about union. So for example, like it's like merging two lists and then keeping unique items only. Then union all combines results and keeps all duplicates. Then it's like stacking two lists without checking for repeats. So there is intersect in some databases where it returns only rows that appear in both queries. It's like finding common items between two lists. Yeah, all these it's just a brief overview, then I'll show you the examples. So the except slash minus in some databases returns rows from first query that don't appear in second. It's like subtracting one list from another. So now these are the examples. So what's union? Combines the result sets of two or more selected statements and removes duplicate rows. So for example, in this example, gonna like select column 1, column 2 from table 1. Then union, select column 1, column 2 from table 2. So the same key rules for union, same number of columns. So both queries must return the same number of columns. So it's not correct to say select name, age. So you're missing column, but the right statement to input, you have to have the same number of columns. Yeah. So in this case, you see that like there is this edge that is missing. Yeah, so you need to have same number of columns. Previously, I highlighted to you the what are columns, tables. Yeah, then there is the compatible data types. So in this case, we are saying name, we have word card, and then union select. But in this case, it's a different type of. Yeah, I think this I need to show you in real time example. So I'll just briefly go through them and then I'll show you the example. So the column names also result uses column names for first query, then order matters for column matching, automatic duplicate removal. So union removes duplicate rows automatically. So use union all to keep duplicates. So let's see an example. So business question, show me all people in our system, both staff, patient and staff for directory. So this is our table, we say, so get all patients. That is, what do you want from the patients? We want their first name, their last name, phone number, then the patient as a person type. So from person, what is the person? Initially, I think, yeah, not here. So I had defined person as just random somebody who I don't even like recognize. So then from the person, I have like this information which I had stipulated in the database that the link I had shared to you. So from the person now, what do you want? You want to join the patients on the person ID, which will equate it to patients and then the person ID. So I'm joining the patients, which is the information here, and from where? From the person who has what? This person ID. Then I'm joining the information into patient's patient ID. So what do I want to join? Then I want to get all doctors. That is their name, last name, phone number, doctor as person, from person. So this person again, it's just a definition, a terminology which I use to say that this is somebody I don't know yet. So I'm giving or I'm requiring this information from, or I'm saying this information belong to a certain person. So yeah, then I'm joining the doctors and person ID. So the result, again, also nurses. So the result here is like the first name is, let's say, Joe, and then the last name Smith, the phone number is this one. Then the person type is a doctor. So this I was just joining this person to patient, and then another one to the doctors, then another part to the nurses. So I'm linking this information of the patients, which is a person, into this person ID. So I'm saying, let me say John and Smith, this is their phone number. Then the person type is the doctor. Then another one is Emma Davis. So I'm unifying the information of this patient so that I can strictly define their identity. That is their identification, this information into the nurse's name. Yes. What else do I need to talk about? Yeah, so union versus union all. So union removes duplicates. So for example, select city from patients. So union select city from doctors. The result is each city appear once. Like for example, this city is linked to patients, and then this city is linked to doctors. So when I query or I want the response, the city only appears once. So union all it keeps duplicates. So what do I mean? So for example, I'm selecting a city from patients, then union all. So the result is cities can appear multiple times. Common states are trying to say union is lower. That is usually it all must check for duplicates. The union all is faster because no duplicate check. So use union all when you know there are no duplicates. Again, I had said initially, it's better for you to know or understand the structure of your database. For example, if you want now to perform these functions, you come from a point where you understand how your database is structured. So when you perform this testing of these functionalities, it's easier for you to handle or manage to lessen the time taken to perform them. Yeah. So when to use union, use cases combining similar data from different tables like you've seen. So for example, all contacts, combine them between patient and staff, then all appointments, schedule completed. So it also creating reports across categories. So revenue by service type or WS. This is just added information I was trying to highlight. So building comprehensive lists. So all medication, you can say I'm combining what do I have or what do we have in stock, what is out of stock. Then out of this information, you can know all the medication available, then the all doctors who are active or on leave. So yeah, this is type of information. Then bad use cases, combining unrelated data. Yeah, for example, names and appointment dates. What do you mean by names? Yeah, name can be just a random individual. Yeah, doesn't relate to appointment dates. Because I can say in these appointments, I need to link, for example, a doctor to how many how many doctors maybe are available for appointment, or how many appointments per doctors do each doctor have. But if I say names, names doesn't specify or doesn't show any correlation or link between these two components. So yes, but that's a bad use case. Then another one is when you need columns from both tables. So you use join instead, not union. Yeah. Another thing is complex relationship. I think this I'll talk about in the use of join in the moment. So yeah, so we have join operations. What is a join? Join combines columns from two or more tables based on based on a related column between them, usually between foreign keys. Like initially, we had specified what actual foreign keys are. So if you have this correlation, then you can now link between the two columns. Yes, yes. Think of it like this. You have two spreadsheets. Then one has customer names and IDs. Yes, and then the other has order details and customer IDs. So join matches them by customer to show customer name with their orders. Yes. So for example, here you have customer names and IDs. And the other you have order details and customer IDs. So these IDs, I can link them between customer name with their orders. This one. So yeah, why do we need joins? So for example, data is split across tables to avoid duplication. That is a problem. And then example in, yeah, again, I'm referring to this. This is the database I was trying to, or I had used earlier. So yeah, appointments table has patient ID and doctor ID, but it doesn't have patient names or doctor names. So those are stored in the person table. Remember the person that I shared or talked about earlier. So this person I had, it was a table that had no correlation between the users or who had or joined the platform. So now, so how do I link between these two scenarios? So I need a join to see John Smith, random name, has appointment with Dr. Sarah Johnson. So these two now I can link them, and I know out of the two, I can say, okay, so John, and I look at our, oh, okay. When I look at our system, I can say, okay, so John has an appointment with who? Dr. Sarah, not another doctor, but specifically this person. Yes, so what are the types of joins? We have the inner join, left join, right join. Yes, we will have examples. I'll just briefly go over them. So inner join only matches, only matching records from both tables. That is table A, union, or inner join table B. Then left join all left table plus matching from right, this I'll explain in the examples. Then right join, you have all from right tables, matching from left, everything from both tables. Now let's see at the examples. So inner join returns only rows where there is a match in both tables. So for example, like select columns, yeah, from table 1, inner join table 2 on table 1 columns. So these are two, they are similar. We want to join them. Real world example. So we have appointments with patient names. The problem we have, appointments table only has patient ID, not patient names. So the solution, select. What do we have? We have appointments and patient appointment ID. Another one, we have appointments and appointments date. Appointments and then the start time. Start time here is starting time of the appointment. Then this person has what? First name. This person also, we had specified this is their another name which they have. This is their last name. Then another person also has a phone number. So this is the information of who, of this person. Yes. So from appointments here, you can say inner join patients on appointments, patient ID. So what are we trying to do? We're saying we start with the appointments table. Let me first go through the inner joins. So inner join person, patient. What are we saying of inner join does? It returns only rows where there is match in both tables. So I come here again and say joins to patient to connect. Okay, join to. So this is we are starting with the appointments table. Then we're saying join to patients to connect appointment to patient. Right. So then again, so where is the patient? We have our patient here in the appointment. So we are joining appointments to patient ID and the patients to patient ID. Then we say, another thing we want to join is person with patients, that is the ID, then the person ID. So what it does, it joins to person to get the patient's name, whereby we have the person or identification we had number to connect with the first name, the last name, then the phone number. Okay, so it filters to today's date only. Where are we trying to see? So where? So we're saying appointments dot appointment date is equals to today's date, which is 10th or 10th November. Let's see. So the result we are saying appointment ID, appointment date, start time, first name, last name, then the phone number. So appointment ID, we have identified it as 101. Then appointment date, we say it's the current date, where it is this one stipulated. Then we said start time is 9, first name, Robert, last name, William. Then we say the phone number. So what are we trying to do here? We are saying in this information, we are joining the patients, that is the appointments, with the patient ID, with the patients, that is the patient's ID. So this is here, it's just, this is a patient. Yeah, so you're joining patients to connect appointment to patient. Then this is just person to get patient's name. Information. Yes, what else do I need to talk about? So qualified columns, column names. So what are they? Format table. Excuse me. So why is it, why needed? Prevents ambiguity when same column name exists in multiple tables. There can be a scenario where you can have like the same column name in multiple tables, so it prevents such occurrence. Another example, let us see. So you have an example problem where you say this is an ambiguous column. Yeah? So you select patient ID, okay, from appointments. Yeah. So you join patients on appointment, patient ID is equals to patient ID. So which patient ID are we talking about? Appointment patient or the patient ID. So this is sort of like an ambiguity where we don't understand what ID are we referring to? Is it the appointments, or is it the patient? Yes, so the solution, so you correct qualified name. So you select appointment as the appointment ID specify, and then we say put appointment dot patient's ID as appointment patient ID. So we are specifying what are we ID of the patient are we linking to. Yeah. So yes, so the best practice always qualify column names and joins clarity. Again, I think I need to emphasize it again. So just be careful in how do you define your database? How do you structure it so that you remove or you limit these type of scenarios in a case where when you want to query data, you want to query information, it is easier for you to handle this, or you basically identify the issues, or like it will be easier, first of all, for you to debug and understand what data links to what. Yes. So I need to talk about table aliases, shorthand. So purpose is to shorten table names for readability. Yeah, I think those, maybe if you go through somewhere, there's a place where I had tried to simplify the appointment ID. So sometimes it's easier for you to say, yeah, benefits, okay. One thing is less typing, easier to read, understand practice in standard practice in industry. Yeah, for example, in this scenario, we have appointment underscore ID. So I don't need to type all this information. You can say, let A be, represent this appointment ID, B represent this, D represent this. So yes, it even isn't for you to reasons for your time. Also easier to read. You can imagine the scenario, you have a very long database, and then you have populated your DB with all this type of information. Yes, just isn't your time typing. Yes. Let's go to left join. For 40. That is not good. Let's continue. So what is left join? Returns all rows from left table plus matching rows. So if no match, null values for right table. Let's see an example. So select columns from table 1, left join table 2 on left. Let's see an example. So real world example, all patients, even without appointments, you want to join them. So the business question is, show me all patients, and if they have appointments, show those two. I need to see who hasn't booked anything. So we come here and say, we select, it's the patient ID, this is the ID, first name, last name, appointment ID, appointment date. So from patients P, yes, this is what I was talking about, table aliases. So we come here and say join person on person ID. So ID. So left join appointments on patient ID and also patient ID. So here I've not specified what or who patients do I want from, or query or return information. Yes, so where appointment date is greater than or equal to the current date, or appointment date is equals to none. So what am I saying here? This is a definition of telling you I just want the patient ID. Doesn't matter, or the appointment date is greater than or equal to the current date, or the appointment date is none. I just want the information of the patient. So what do we get here? Like an example, patient ID. We have one, and the first name Robert, last name William, appointment ID, appointment date. Yes. So, yeah, the only thing I just want is the patient. Return me the patient. So the key Linda joins appears even though she has no appointments. As you can see, yeah. So here you're saying Robert Williams had an appointment. What time? This time. This time, yes. And then you have Mary Smith has an appointment when? This time. At what time? 14. But Linda Jones doesn't have any appointment date. But again, I just want the return of the patients. So yes, that is, so when to use left join. Good use cases, finding missing data. So for example, you want I just want information about who, I mean, for example, in this scenario, patients without appointments or doctors without patient. That's the information I want. That's one use case of left join. Because the another thing is optional relationship. For example, employees with or without partners. I just want information about employees. Then another thing is orders with or without shipping info, just adjustment orders. Yeah, so these are just the examples. Another example I'm giving here is doctors who haven't seen patient this month can stipulate here, and then this is just another version of saying how can we use left join. Let's go to the right join. So what is a right join? Returns all rows from right table plus matching rows from left table, opposite of left join. Let's see an example. So now right join is less common, as most people just flip the tables and use left join instead. Yes, that's just a note. Let's see an example. So let's say right join, select, for example, select everything as the means everything from appointments, and then right join patients on. What is it supposed to be? Join.
Leonard, tell us, are you a doctor?
Again,
Thank you, guys.
technical
Eh?
issue.
Eh? Come again?
Technical issues again. So leo
Mm,
haijakuwa nzuri.
it's okay, pole. It's okay.
No
Do you
worries,
need
no
some
worries.
assistance?
There is just a small part in the back here. The only thing is the network issues. That's the main problem. But I'm
Pole,
remaining
pole.
with something small to finish.
All right. All right. So we wait for you, kidogo.
Yes. Yes.
All right.
Already I'm sharing this.
Yes, you are. We can see the doctors who haven't seen patients.
Good. Awesome. Awesome. So I just finish, and then what are we remaining? This, I think this example, I'll leave them to you. So just briefly say, then yes, that I think before I was left join, we've talked about it. How to use, I've said it. Right join, yeah. Multiple joins, yes. So the right join, so it returns all rows from, I think I've said it. So we are from the example. So here you're saying select everything from the appointments, right? So I want everything from appointments, then right join patients on appointments dot patient ID, which is equals to patient ID. So yeah, then another thing is left. So these are just comparing between left join then the right join, so that you can see the difference between the two. Yes. Multiple join complex queries, joining many tables. So scenario, show me appointment details with patient name, doctor name, department, appointment status. So how are we going to do this? We say, so we have the appointment date, appointment ID, start name. So the patient info is this one. So patient person, first name as patient, first name. I'm saying, say this is the patient person. Then we want the first name as patient first name, and the patient person last name as this one. Then the doctor info, the same thing. Then the department info, I'm saying this is the department name and then the status info is the status name. Yes. So from appointments, that is this one. They say join to get the patient's name. So join patient, that is patient ID goes to patient ID. So this patient is from appointments, as you can see. Then this patient ID is from person. Yes. And then the join person, that is the patient person on patient person ID with patient. Yes. So okay, let me see. I think this is difficult for me to read each step by step, but I'll just briefly tell you what it means. Yeah. So we have the joint doctors, that is on a doctor ID as opposed to a doctor ID. So this is a representing appointments. D, we have the doctors, then joint person, doctor person, doctor ID, which is doctors again, doctor. Okay. So here I'll just say what it means. So we have a joint chain, where we have the appointments, yeah. So these appointments, I'm linking them to patients, yeah. And the patients, linking them to a person, which is the patient name. Then also here I'm saying patients link them to doctors. Then from the doctors, I'm linking them to the person who is the doctor name. Again, here I'm saying patients, appointments, I'm linking them to departments. Departments, again, I have the department name. And here again, I'm saying appointments, I'm linking them to appointment status. So what is the status name? So that is the join chain. I think I'll leave you with the example so you go and see how can you play around with them. Then the best practices for multiple join. Start with the main table, usually the one with the most important data. In this case, we're going to have the appointments, then use meaningful alliances. Again, this is very important so that you can know what am I talking about in the future when you're querying information. It will be easier for you to correlate or link them with whatever information you want to get or acquire in your DB. It's so clear which is which, common joins, explain what each join does. Very important. Also help others in the future to understand. You'll be in a group scenario as environment where you're basically you're working with a group, yeah. So they need to understand what are you talking about or what are you doing with the database. So this is key. Define your statements or explain what you're doing. So test incrementally. So add one join at a time. Yeah, this one can be messy. Whereby you want to handle a lot of information, a lot of joins, becomes messy even to query, even to understand what's about. So add one join at a time. It's a common join pattern. I don't think I need to go through all these. It's just examples as showcasing. Find more in the group I had shared this document. So performance consideration, index your foreign key. Why? Joins are slow without indexes foreign keys because you are linking between different information or different columns, different tables. So you need to specify, did I say tables? Sorry, columns. So you need to specify what key or defines what or relates to what type of information. So yeah, join order matters sometimes. Yes, it matters because when you're query information, need to understand the link, because you can't say, let's see an example here. Start with the smallest table where possible. Filter early where close before join is, where close before join is possible. So in a scenario, let us see this scenario. So filter appointments first, smaller results set. So from appointments, we say join patients on patient, that is appointments, then we have the patient ID, then the patient, this is for the person, then where appointment date is equals to current date. The filter add is this where it was join everything. So you say from appointments, join patients on patient ID, join person. So this is a let filter where you don't, it becomes even difficult to understand what am I doing, what patient am I linking to. So yes, avoid Cartesian products. A lot of information again to just tell you some good examples to use cases, more mistakes, how to avoid them. Wrong join type, where left join. Yeah, more information. Have them even practice exercises which you can go through, list of phone numbers. Yes, exercise also to try and see what you can do about union purpose, that is stack results from multiple queries, then the rule, same number of columns, compatible types, when do you use them, combine similar data, different sources, so remove duplicates, inner join, where to use them, their purpose, their rule, remember most common join type. A lot of information again, so left join, keep all rows. This, I think, is something you can go through. Best practices, next steps. So need to practice. I think I maybe can from the the database that I shared earlier, can just test these scenarios. Yes, I don't think I have other much to add on or say. Let us go back to the LMS and see what's remaining. Yes, a lot of info in a short time. Okay, what am I looking for? How is the session? And how is everything? Let's see the chart. Any questions? And as you didn't come out saying right joins are rarely used because operation can be rearranged to make use of the less join. Thank you, Gideon. Yeah. What else do I need to talk about? You're a real doctor. No. It was like why I used that scenario as an example where we were told to like create a table or create a database involving doctors. So I was trying to see how many scenarios can I think around the hospital environment. So that's why I was trying to like create all those functionalities, those functions. So no, I'm not a I'm not a doctor. Yeah, but thank you for the question. Thank you, Musembi. Yeah, I did some research trying to understand what can I cover in detail about the hospital environment. I think the database will deeply showcase what I was trying to explain in slides. I'm trying to connect to another screen. Like yes, this one. Yeah, I'm trying to see what are we remaining with. What you learn, key terms, no, not this one. I think it was not functions. Yeah, no, this one we've discussed. Retrieving data, yeah, this one. So what have we talked about? Set operators, union all, set, minus. Have I talked about minus? Used to combine two result sets and return data from the first result set. I don't think I've interacted with this one. Union operator example, we said about this one. Union all, yes. Trying to see joins, to see join close. You have inner left, right, full. Inner join returns the rows that match in both tables. You have left join, returns all rows from the left table, the right table. Yes, I think this one you can now go back and see what is working, what will work, to not work. Yes, for example, you have city, country, output, joining the two, have inner join and the right. I'm saying they want from right, left, yes. You have the output, there's the country. Left join, that's the scenario. Full join, combining the two, have the output. Do I need to repeat it again? Have the inner join example. Go more about it. Country code. What am I looking for? Okay, pass function. Did I see Angela also talking about us before? Yes, I saw this one. Notice this example. A lot to go through. It was just highlighting. Yes, you can do this. What is a join? Yes, class. What is a join? Let me go to the chat. Swali ni ya Gideri. Yes. What is a join? Mwalimu Pat akijibu ongezea marks. Yes. Let's see from the chart. What is a join? What is a join? It's 5 p.m. Oh, okay. So crazy. We go through the answers mbio. Yes. So a join, you can use a join to combine data from two or more tables. So what does a union do? A union operates an operation combines the results of two queries into one result. I see Gideon Across used to combine two rows. Thank you, Gideon. Gezia marks. Yes. Add more marks to Gideon. I'm sorry, Gideon. What else? Key takeaways. Go to. Somebody is laughing. Yes. As we conclude, we are saying key takeaways. You can use the union operator to combine two or more select statements. Okay, this process outputs a single result set. You can use a self join to join. Yeah, these are just key takeaways. Yes, thank you for completing this module. Thank you very much. Yes. I think that's all for me. Yeah, thank you for your participation. Thank you. Any clarification, notes? They have provided the notes in the chat, in the WhatsApp group. So if more clarification, also provided the database link, GitHub. I don't know if I drop it again. I don't know. Give me feedback. Do you need the database to query, to check it out? Provide me info kwa chat hapo. Yes, but thank you for the opportunity, Lanli.
Karibu sana, Leonard. We appreciate. 10 more marks to Gideon. 10 more marks to Gideon and Musembi. Those are the only two people who have talked the entire afternoon, apart and Mark. Yeah. Oh, and also Ivy and Nicodemus. Oh, people, you're so quiet. Your day is coming. And be rest assured, tutawachekelea. Who is that? Ameuliza why a joke to you. Justin. Oh, yes, and Justin. No, you're not a joke to me. 10 more marks, 10 more marks. Pole. No, guys. We Angela.
Yes.
Thank you to your team. I really appreciate. Now, I do not think we'll get enough time for introduction to AWS database services. What do you think? Are there not so many?
There are not so many, but also Brian, who was supposed to do it, is not in the meeting. So I'm thinking if you could allow us tomorrow, 30 minutes.
All right.
Yeah.
All right. No problem. No problem. And as we're talking about that, as we are talking about the 30 minutes to Angela, we are very, very sorry for a few changes that we have done because let me just share this with you guys. Ball out here. Let me see how I can display this alone. Perfect. All right, so let me share my screen and show you. And perfect. I think I can show you this. Nisimwage mtama ya kazi. Mwenyewe hapa venye najitetea. So, chekeni tu. Sorry, Leonard and Angela and Belinda and Nicodemus. I know it can be, and it can be tough and it can be tough. So guys, allow me to share this screen kidogo too. And here, we have, so today we have just finished with introduction to databases and data types. Thank you so much. So now tomorrow because we unfortunately presented Team Edge's work, we moved the days, we moved the other lessons ahead, and tomorrow morning we'll have an introduction to RDS by Team Brave. Team Brave, hola. Team Brave, where are you? Team Brave, anyone from Team Brave? How brave are you if you're quiet? Allah. No one from Team Brave.
I think they have raised their hands. Kina Sharon.
Oh, they've raised me. I thought they were unmuting. Oh, sorry. Let me open my participants window.
Sharon, see you are the
Sharon.
ones.
Yes.
You see,
sorry.
those people are brave. Jay, can I say something? Okay. Uh-oh, it's my internet. Okay.